10, question 10, part 1. And the initial velocity is given as 10I plus 98j. So let's look at the question. So a particle is projected from a point on a horizontal plane with an initial velocity of 10I and 28j. Find the time when it reaches its maximum height above the plane, its position vector at this time. Okay, so the time, so we have something here. It travels in the I at 10, and in the j it will be 98. So that's the initial velocity. So it looks like it will be firing up something like that. Okay, so that's that. Now, if that's the situation, we want to know what is the time at which it reaches a height. Oh no, sorry, a maximum height. Yeah. So the maximum height here. This is here. The things that are special here are, first of all, well, you're halfway through your time, so you could get the time without being half it. Or it's also time for when the velocity y equals 0. So if you get the time when the velocity y is 0, because obviously this thing is firing up and it stops and then comes back down. It just happens to also have a horizontal velocity of 10, which means that it goes in this shape. Otherwise it would just go straight up and down. Okay, so U, V, A, S, and T. So let's show them in. Again, it's only the y bits I'm interested in. So the u in the v is 98. The v here, u in the y is 98. The final velocity is 0 because it gets the top. Acceleration is always 9.8. And the distance I'm not interested in, the time I am, that's the time to go halfway. And that is the question. That's what we're looking for. Okay, so I think I'll use v equals u plus at would be the right equation to use. So 0 equals 98 minus 9.8 t. So these are nice numbers you can see. So minus 98 divided by minus 9.8 equals t. So that would be t must equal 10 seconds. So the time up here to get up here is 10 seconds. So straight away we know that it would actually take 20 seconds to get to here, but we weren't asked that. So that's the first part of the question.